Alright, in this video we're going to look at the first three review problems. First off, we flip a coin 6 times. And when we flip the coin, say the first coin could be heads, the second one could be heads, the third one could be tails, the fourth one could be heads, the fifth one could be tails, the sixth one could be heads. How many different runs are possible of flipping a coin 6 times? This one's a multiplication problem using the product rule. So there are 2 possibilities for the first coin. There are 2 possibilities for the second coin. There are 2 possibilities for the third coin. There are 2 possibilities for the fourth coin. There are 2 possibilities for the fifth coin, and also 2 possibilities for the sixth coin. So the answer is simply going to be 2 times 2 times 2 times 2 times 2 times 2. If I said it right, I said it 6 times. So 2 to the 6th, which is equal to 64 using the product rule. So that's the answer to 4.1. 4.2. How many words of length R can be formed from the English alphabet, whether or not they appear in the dictionary? And we'll permit a capital letter to be the first letter, but all other, so the first letter could be capital or lowercase, but all other letters must be lowercase. So for this one, we have 52 possibilities for the first 52 possibilities for the first letter. The first letter could be either capital or lowercase. So 26 plus 26, 52 possibilities for the first letter. After that, every other letter, there are 26 possibilities, and there are R minus 1 remaining letters. So this would be one way to write the answer, 52 times 26 to the R minus 1. That would be a correct way of writing this. And that means there's 52 possibilities for the first letter and 26 possibilities for the R minus 1 remaining letters. This can be simplified somewhat. We can write this as 2 times 26 times 26 to the R minus 1. And then I can combine to write 2 times 26 to the R. So this is correct, that's a little simplified and also correct. But the basic logic is there's 52 possibilities for the first letter and then 26 possibilities for the remaining R minus 1 letters, and I multiply. For problem 4.3, how many functions are possible with domain 1, 2, 3 and codomain 4, 5, 6, 7, 8, 9? How many functions are possible? So when listing out a function, I have to say what f of 1 is, I have to say what f of 2 is, and I have to say what f of 3 is. So for every number in the domain, I have to give a number in the codomain. Well, there are 6 possibilities for what f of 1 could be, there are 6 possibilities for what f of 2 could be, and there are 6 possibilities for what f of 3 could be. And so for part 1 here, the answer would be 6 to the 3rd, 6 times 6 times 6, or 216. Because there's 6 possibilities for the first, 6 possibilities for the second, 6 possibilities for the third. A somewhat more interesting question is part 2, how many one-to-one functions are possible with the same domain and the same codomain? Now once again, for f of 1, there are 6 possibilities. However, if the function is one-to-one, then f of 2, whatever this is, can't be equal to f of 1. These two numbers cannot be the same because it's supposed to be one-to-one. So if there's whatever this number is, there are 6 possibilities, but here there's only going to be 5 possibilities because whatever the number is here can't happen. So 6 times 5. Then for the third function value, this number can be anything except for the 2 that are up here because the function is supposed to be one-to-one. And so there's only 4 possibilities for the third function value. So to go over this again, there's 6 possibilities here, but if the function is supposed to be one-to-one, then this value can't be the one here, and this value can't be either of the 2 here. So the answer is 6 times 5 times 4, which is equal to 120. So there are 216 functions that go from here to here, but only 120 of them are one-to-one functions.